The next thing I just want to look at is transformations on the complex plane. And this can sound awfully tough, and you think, oh, I'm not up for this. Must be something to do with honours maths, and it has, and it hasn't. It's also just very simple. It comes off the junior cert as well. To find the image where it goes to of a complex number under a given transformation, we do the following. Write the complex number as a point with the real part first. So you have 5 minus 4i, 5 comma minus 4. And if you have minus 2 plus 3i, then it's minus 2 comma 3. Perform the transformation, whatever that is, move it, in other words, to find the image exactly as done in coordinate geometry. And then rewrite the image point as a complex number. So if you have minus 1, 6 as an answer, it's minus 1 plus 6i. And if you have 0, 2 as an answer, it's just 0 plus 2i. Now this seems like quite a mouthful there, but let me try and illustrate it with an example. Find the image of 3 plus 2i by central symmetry in the origin. Now there's 3 plus 2i there. Or you might say 3 comma 2. And when you see central symmetry, I say I prefer the word reflection. R-E-F-L-E-C-T-I-O-N. Reflection. So in other words, where's the image of that? So the origin is the mirror in this case, and there's the 3, 2. You come down there and out the far side the same amount. And this is a transformation. And I find if I do this in class and people are really paying attention, they say, is that it? And they're disappointed almost. And you have to say, yes, that's it. A transformation is when you move something. Great. So all I have to do then is draw the Argand diagram of it. So 3 plus 2i is here. There's the origin. Go right through the origin and out the far side to there. And there's the answer. So the image of 3 plus 2i is minus 3 minus 2i. There it is there. Notice the distance from 3 plus 2i, the distance from there to there, that distance, is the same as the distance from the origin to here. Sorry, the same as this one here. That distance is the same as that distance. So it's very, very easy if you're somebody who's willing to draw the picture out. B, find the image of minus 2 plus I by axial symmetry. And again, that's the reflection word. Reflection in the real axis. This one's the real axis, this one's the I-axis. Now the students in an exam look at this and think, oh, I've forgotten which is which, or I never knew. And that's a pity. So the real axis is the one that was the x-axis originally. So there's minus 2 plus I. And where's its image? If the real axis here is a mirror, then you look through and you're just out the far side to here. So the image of minus 2 plus I is minus 2 minus I. So minus 2 plus I by reflection in the real axis is the same as axial symmetry in the real axis. And it gives us an image of minus 2 minus I. And again, we notice that the distance from there to there, that green piece, is the same as this hop here. Okay, last one. Find the image of 1 minus 4 by axial symmetry in the imaginary axis. So it's another transformation. So these are just 3 very easy transformations that we have. There's 1 minus 4i there. This here is the imaginary axis. There's the name, but there. So you're going to come through and out the far side. And what we need to remember is the distance from there to there is the same as the distance from there to there. So if this one's 1 minus 4i, this one is minus 1 minus 4i. Same idea in all of them. So now, I'm now ready to have a look at a couple of exam questions with little twists in them. So in section 4, for 10 marks, u is equal to 6 minus 5i. Solve for real a and real b. U plus ai is equal to 2b. Now lots of students will look at this and think, wow, never did one of these before, this looks awful. And it looks awful, but it's incredibly simple. So what do you do? Well, here's what you do. U is replaced by whatever he gave you in the question. U is replaced by 6 minus 5i. The ai is just left sitting there for the moment, and the 2b, and we see what happens next. So if I get rid of that, then I've read the question, and I really am a bit confused. So u plus ai is equal to 2b. So I'm replacing the u by 6 minus 5i. So there I have 6 minus 5i plus ai is equal to 2b. So what have I done? I've just put the u in there. And that gets you the 3 marks in the exam. That's the attempt. That's a good move. Now, these questions are very confusing for students, but for me, I say to people they're as easy as a Sesame Street program where Bert collects the I numbers. If you're familiar with Sesame Street, you'll know the characters. If not, it doesn't really matter. They're just two people. Well, I suppose people is a bit strong a term, but they're two guys who hang out on Sesame Street. So Bert says the real parts are the bits that I collect. So Bert collects real bits. So Bert will collect the 6. He won't collect the minus 5i because it's not a real part. He won't collect the ai because it's not a real part either, is equal to 2b. So Bert will come up, he'll collect 6 and he'll collect the 2b. He won't collect anything else. So Bert will tell me that 6 is equal to 2b, so b is equal to 3. Later on in the program, we'll get Ernie to come along and he will be asked to collect the things that have the letter I. So you could say today Sesame Street is brought to you by the letter I. And here, when we talk to Ernie, we'll say to Ernie, okay Ernie, collect the I parts. And Ernie does what he does best, he collects the I parts. Here's 1, minus 5, yes, good old Ernie. Anything else, Ernie, with an I part? Yes, the A, there's the A, super, AI, so that's that. Equals, there's no I parts on this side, so Ernie has nothing to collect over there. So minus 5 plus A is equal to 0, so A is equal to, add 5, and you're home free. So, nice question. Strange idea, I think, and once you handle it, it's fine. Lots of people you see in an exam just miss the point completely, which is a pity because it's very, very doable.